Welcome to Intelligence Gateway. What are the regulatory challenges of 5G technology? The regulatory challenges of 5G technology include issues related to spectrum allocation, infrastructure deployment, and data privacy. Governments must balance the need to promote innovation and investment in 5G technology with the need to ensure that the public interest is protected. This includes ensuring that spectrum is allocated fairly and efficiently, that infrastructure is deployed in a way that minimizes environmental impact, and that data privacy is protected. Additionally, there may be challenges related to cross-border cooperation and coordination between regulatory bodies. What is the role of spectrum management in 5G technology? Spectrum management is critical to the deployment of 5G technology, as it involves the allocation and management of radio frequencies that are used to transmit data over wireless networks. To support the higher bandwidth and faster speeds offered by 5G networks, more spectrum is required. Spectrum management involves ensuring that there is sufficient spectrum available and that it is allocated in a way that promotes competition and innovation, while also ensuring that interference is minimized. What are the different 5G testing and certification requirements? The testing and certification requirements for 5G technology vary depending on the region and the specific application. Generally, these requirements include testing for compliance with technical specifications and standards, as well as for performance and interoperability with other systems. Additional requirements may include testing for security and privacy, electromagnetic compatibility, and environmental impact. What are the different 5G testing and certification organizations? Several organizations provide testing and certification services for 5G technology. These include industry associations such as the 5G Automotive Association, 5GAA, and the 5G Infrastructure Association, 5GIA, as well as standards bodies such as the Third Generation Partnership Project, 3GPP, and the Institute of Electrical and Electronics Engineers, IEEE. Additionally, there are independent testing and certification organizations such as ETSI and TÜV-SÜD. What are the different 5G testing and certification processes? The testing and certification processes for 5G technology typically involve a combination of laboratory testing and field testing. Laboratory testing is used to evaluate compliance with technical specifications and standards, while field testing is used to evaluate performance and interoperability in real-world conditions. Testing may be performed by the technology provider, a third-party testing organization, or a combination of both. What are the different 5G testing and certification criteria? To ensure that 5G networks and devices meet the required performance standards, various testing and certification criteria are established by regulatory bodies and industry organizations. These criteria are designed to evaluate different aspects of 5G technology such as network performance, security, interoperability, and compliance with relevant standards. Some of the key 5G testing and certification criteria include: radio frequency, RF, performance, evaluates the signal quality, coverage, and interference levels of 5G networks and devices. Interoperability ensures that different 5G components and devices can work together seamlessly, regardless of vendor or technology. Security tests the security features of 5G networks and devices, including encryption, authentication, and authorization mechanisms. Energy efficiency measures the power consumption and energy efficiency of 5G networks and devices. Compliance with standards verifies that 5G technology adheres to relevant global and regional standards, such as 3GPP and ITUR. What are the different 5G testing and certification tools? To conduct tests and certify 5G networks and devices, various specialized tools and equipment are used by network operators, equipment manufacturers, and regulatory bodies. These tools help to measure and analyze different performance parameters of 5G technology, such as signal quality, latency, throughput, and power consumption. Some of the key 5G testing and certification tools include Network analyzers, used to measure and analyze the performance of 5G networks, including signal quality, power consumption, and throughput. Protocol analyzers, used to monitor and analyze the signaling and data exchange between 5G network components and devices. Spectrum analyzers, used to detect and analyze radio frequency interference in 5G networks. Channel emulators, used to simulate different radio channel conditions and evaluate the performance of 5G devices and networks in different environments. Network simulators, used to simulate and test the performance of 5G networks under different traffic loads and network conditions. What are the different 5G testing and certification metrics? To evaluate the performance of 5G networks and devices, various testing and certification metrics are used by network operators, equipment manufacturers, and regulatory bodies. These metrics help to measure and quantify different aspects of 5G technology such as speed, latency, coverage, and reliability. Some of the key 5G testing and certification metrics include: data throughput measures the amount of data that can be transmitted over a 5G network in a given period. Latency measures the time delay between a request and response in a 5G network. Signal quality measures the strength and reliability of the 5G signal, as well as the level of interference and noise. Coverage measures the extent of the 5G network's coverage area and signal strength. Energy efficiency measures the power consumption and energy efficiency of 5G networks and devices. Reliability measures the consistency and reliability of the 5G network's performance, including the rate of dropped calls and lost connections. What is the 5G testing and certification roadmap? The 5G testing and certification roadmap involves a series of steps to ensure the proper functioning and interoperability of 5G networks and devices. The process typically includes testing of the individual components, such as radios, antennas, and network equipment, as well as the overall system performance. The testing may also involve the simulation of various scenarios and use cases to verify the network's capabilities. Certification is then granted to devices and equipment that pass the testing requirements, which helps ensure. What are the different 5G implementation strategies? There are several different 5G implementation strategies that network operators can use, depending on their specific goals and resources. Some of the common strategies include non-standalone, NSA, deployment, standalone, SA, deployment, dynamic spectrum sharing, DSS, and small cell deployment. NSA deployment involves using 5G radios alongside existing 4G infrastructure, while SA deployment involves building out a completely new 5G core network. DSS allows 4G and 5G devices to share the same spectrum, while small cell deployment involves installing small radio access points to enhance coverage in densely populated areas. What are the different 5G deployment models? The different 5G deployment models include Centralized Radio Access Network, CRAN, Distributed RAN, DRAN, and Cloud RAN, CRAN. CRAN involves consolidating baseband processing in a centralized location, while DRAN distributes processing across multiple sites. CRAN provides greater scalability and flexibility, while DRAN offers lower latency and higher reliability. CRAN involves using cloud computing to provide processing and storage capabilities for the network. What are the different 5G deployment scenarios? The different 5G deployment scenarios include enhanced mobile broadband, eMBB, massive machine-type communications, MMTC, and ultra-reliable low-latency communications, URLLC. eMBB involves using 5G for high-speed data transmission, while MMTC involves connecting a large number of devices with low data rate requirements. URLLC involves providing low-latency, high-reliability communication for critical applications such as remote surgery or autonomous vehicles. What are the different 5G deployment challenges? The different 5G deployment challenges include the need for new infrastructure, including small cell deployment and fiber optic cabling, as well as the high cost of 5G equipment and the need for additional spectrum. Other challenges include the complexity of 5G networks and the need for skilled personnel to deploy and maintain them. Regulatory issues, such as spectrum allocation and zoning laws, can also pose challenges to 5G deployment. Thanks for watching. For more information, like, comment, and subscribe our channel.